welcome to video 2 of atoms, elements and compounds. Now we're going to look at compounds. Now the definition of a compound, as we probably know, is two or more elements bonded chemically together. All right. In other words, there's some sort of formal link between the atoms. They are bonded. They are stuck together somehow. We don't have to know how for now, but they are stuck together somehow. All right. So two or more elements. So, for example, if you have a nitrogen, there's a nitrogen atom, and there's another nitrogen atom. The whole thing forms a molecule. Okay, and there is an interaction between one atom, this atom, and this atom. Okay, and this thing between them, what holds them together, is called the bond. All right, that's what keeps them together. Now, is this a compound or is this an element? Well, it is a molecule, but each part of the molecule is made up of the same type of atom, so this would be regarded as an element. But if we look at something like nitrogen, all right, and then we bond it to oxygen, like that, and this becomes nitrogen monoxide now. This thing is nitrogen monoxide, and this, obviously, the two atoms, okay, are different. Okay, so this would be regarded, this thing here is a compound because the atoms are different. Simple as that. And again, in this area here where they're touching, this is the bond. Okay, so they're bonded together. So a compound is two or more elements bonded chemically together. All right, now any compound, for example, water, carbon dioxide, ammonia, sulfuric acid. All right, if we were to draw these molecules, water would look like this. Carbon dioxide would look like this. Ammonia would look like this. And sulfuric acid would look like this. More complex molecule, sulfuric acid, would look like that. As you can see, they're in a set ratio. The atoms in a compound are in a fixed ratio. Okay, they're not higgledy-piggledy. So in water, you have two hydrogens and one oxygen. It's always that. So the formula of water is therefore H2O. It's always H2O. All right, CO2, carbon dioxide, is one carbon and two oxygens. NH3 is one nitrogen, three hydrogens, and sulfuric acid is two hydrogens, one sulfur, four oxygens. So they're in a fixed ratio. In a compound, they're in a fixed ratio. Are compounds pure things? Well, surprisingly, lots of students find trouble with this, but yes, they are pure. Yes, they are pure. Why are they pure? Why are they pure? Because they only contain one substance. Okay, now the substance might be water, okay, or carbon dioxide. All right, but water is a substance on its own, and carbon dioxide is a substance on its own. So compounds can be pure, well, they are pure, and the atoms are in a fixed ratio. Okay, obviously we can get solid compounds like sodium chloride. We can get liquid compounds like water, and we can get gaseous compounds, as we've said, like carbon dioxide. All right, but you can get solid liquids and gases of these, they're compounds. What are solid things? What's sodium chloride made of? Well, interestingly, we haven't mentioned it. Well, we mentioned it quickly, but these are made of ions. Liquids, H2O, this is made of molecules. And CO2 is also molecular, so we call this molecules as well. Okay, now I've got a very short time to do mixtures in, but that's okay. So what's a mixture then? Now mixtures, these are not pure. Okay, they're not pure. All right, so a mixture would be something like, let me draw a nice picture here. Now we've got a glass of water, and these are H2O molecules. So let me draw my little H2O molecules. All right, these are H2O. Okay, and it's pure at the moment, it's pure water, but if I put into that something, if I dissolve into this sodium chloride, Yeah, sodium ions. Oh, that's wrong. It's not 2 plus. It's plus 1. The sodium ions and the chloride ions will mix up with the water. Okay, so this is salty water, really. So this would be NaCl aqueous. This is sodium chloride dissolved in water, and it is not pure. What do we mean by not pure? Well, there's not one substance. Okay, there's more than one substance. And are they in a fixed ratio? No, they are not. They are present in any ratio. Okay, so at the moment, if I've got sodium chloride in water, it's a mixture. It's a mixture of two things. If I add more sodium chloride, it's still a mixture. Okay, if I add loads and loads of sodium chloride, it's still a mixture. If I add more water, it's still a mixture. So mixtures are not, they're not in a fixed ratio. We can add loads of one stuff, loads of another stuff. Okay, so mixtures are impure. All right, compounds are pure and elements are pure, but mixtures are impure. Now that's let me summarize that very quickly. So we have elements, these are pure. Compounds are pure things. But mixtures, these are impure. Different color, impure. And because of that, because these things here, like for example, they're not bonded together, are they? The components of a mixture are not bonded together. Mixtures are relatively easy to separate. We can separate out the components quite easily. Okay, compounds, it's very hard to separate bits of compounds. We can do it, but we can't do it easily. Okay, we can't separate out the components of an element because there's only one thing there. So elements are pure, compounds are pure, but you can actually separate if you wanted to. You could take water and create hydrogen and oxygen from it, but it's not very easy. You can't do it in a laboratory easily. All right, but mixtures, they are easy to separate because they're not chemically bonded together. The components aren't chemically bonded. All right, so we're done with this one. Thank you very much.